Here's an explanation for the answer to final exam question number 74 in Electronics Demystified, 2nd edition. If you have the printed book, you'll find it on page 433. The question reads like this. In a set of resistors connected in parallel, the voltage across any particular resistor equals the voltage across any other resistor, and the total wattage dissipated by the entire combination equals what? And then we're given 5 different choices based on the wattages in the individual resistors. Well, this is a rendition, what you're looking at here, of figure 1-6 in the book, rearranged a little bit to fit on this screen. Notice the total wattage dissipated by the entire set of resistors is equal to the battery voltage, or the power supply voltage, multiplied by the current that the entire set demands from that voltage source. Notice here that I have rendered current going from plus to minus. That is called conventional current, and it's the original way that current was defined before they knew what electric current actually was. They didn't know about electrons and that they had a negative charge, and so they just figured, well, it makes sense to say you got polarities, plus and minus, and current must flow from plus to minus, obviously, from more to less. That was all the way back in the 1800s before they really knew what current actually consisted of in a circuit like this. Anyway, that's the reason why this arrow points in this direction. It doesn't really matter in this circuit what direction the arrow points. Well, we can calculate the amount of power dissipated by each and every one of these individual resistors, R sub n, if we multiply the battery voltage E times the current through that particular resistor, I sub n. Shown in this diagram, we've tapped an ammeter into that particular branch only, so we can say that the total power, P sub n, if we wanted to call it that, would be the battery voltage E times the current here, I sub n, and that would be true for each and every one of these resistors, where n in this circuit diagram could equal 1 up to 5, R sub 1, say R sub 2, R sub 3, R sub 4, R sub 5. Okay, so remembering now, in a parallel circuit, the voltage across any one of these resistors is the same as the voltage across any other of these resistors, namely the battery voltage E. But the currents through the resistors are different, depending upon, of course, their ohmic values. We can calculate using Ohm's law, I equals E divided by R sub n for each and every one of these. And we're going to get, if the values are all different, which they would make the situation a little complicated to calculate with numerically, but here we're dealing in generalities. We'd get a different current, but the total current I drawn from the battery here by the entire combination is going to equal the sum of these individual I sub n's. So we could say that this power right here, the total power, is equal to the battery voltage times the sum of the individual currents through each one of the resistors. Well, it doesn't take an algebra wizard to figure out that that means that this total power P is going to equal the sum of the individual wattages demanded by each one of these resistors in turn. So this amount of power plus 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 this amount of power is going to give us the total power P. Well, that's a roundabout way of saying that the correct answer to this problem is choice C. The total wattage dissipated by the entire combination of resistors equals the sum of the wattages dissipated in the individual resistors.